Hello everyone, this is my first educational video and I'll be covering the topic of propositional logic, which is a branch of logic covered in discrete mathematics and computer science. So let's dive in. So propositional logic focuses on truth versus falsehood. So basically, if it's right or wrong, or this or that, it doesn't capture the real world complexities and nuances, unlike first order logic, which will be a topic covered in the future. So there are 5 symbols in propositional logic. Those 5 symbols are the and symbol for a conjunction, meaning both the conditions have to meet. The or symbol for disjunction, meaning the two are separate from each other. Either of those have to be met. And then after the and or, there the implied symbol, which is a right-facing arrow. Then a two-facing arrow for biconditional. And the last symbol is the negation. So this is a way to start off with propositional logic. We need to know these 5 symbols before we proceed any further and make sense of the topic. So before I delve in further, I'll give you some real world examples and then go into using true versus false values, which is a hallmark of a lot of programming work. So you can say Tom is a boy and Tom is a male. And this is for the and example. And now if we go into the or example, we can say the person is happy or the person is sad. And this is for the or example. Now that we covered the first 2, we'll be going into the last 3 symbols. So for the implies, an example is Tom is an engineer, then Tom is an employee. That's for the implies. Now for the biconditional, we can say Tom is a male implies that Tom is a human being, and even in reverse from common sense, that's true. So now we covered the biconditional. Now for negation, I'm going to randomly pick one of the examples here. So I'll be going for the second example. You can just say not, meaning for negation, and say sad. So I gave you some real world examples. Now to go into a little bit more of a mathematical perspective, we'll be using two variables, and I'll call them C1 and C2, meaning condition 1 and condition 2. So now to see this from a mathematical perspective, there's a concept of a truth table, which takes into account of the different conditions and also evaluates based on the subsequent conditions of concern here. C1, C2 are the two variables I said earlier. Now I'm drawing a truth table. C1, C2, and if we AND the C1 and C2, or C1 or C2, C1 implies C2. One more column we could make is the C1 biconditional C2. So let's say for condition 1 and condition 2, we choose both the values to be true. If both the values are true, then it would evaluate to true. And this is also based on circuit logic. So more positive value would yield the upper hand. Or say between 0 and 1, 1 would yield upper hand. Now for C1 or C2, it's either true or true. Since either of the conditions can be true, then we would go with true. And if true implies true, we obviously get true. If true implies true one way, and true implies true the other way, then we get true. So we finish the first row. Now, we're going to make C1 true, and then C2 false. Here, we're doing true and false, and that's not possible. It cannot be true and false, so we'd go with false. But true or false is possible, so we'll go with true. then true cannot be false, so the implied condition won't hold. And then the same the other way around for biconditional. Now, if you make the first value false and the other value true, so again, false and true would evaluate to false. Then false or true would evaluate to true. And false implying true means, yeah, something is false, then, and if it's implying some truth out of it, it would be true. But the other way around, it won't hold. If something is true, it cannot be false. Now, if you make both the values false, then false and false would evaluate to false, because both the values for false, like, it's ultimately false. And for false or false, you'd have false. Now, when we come to false implying false, it would evaluate to true. Something is false, it obviously is going to be false, and that would evaluate to true. And the same holds biconditionally as well. So that finishes the concept of propositional logic.